Welcome to the Control Engineering webcast, Fueling Advanced Analytics with Industrial Data Management, sponsored by GE Digital. I'm your moderator, Mark Hosky, and I'm happy to join you today on behalf of Control Engineering and CFE Media and Technology. Here are some tips to help you get the most from today's webcast. If you're experiencing issues with your slides or audio, refresh your browser or click the Refresh Media button directly under the presenter's picture. You can control the volume of the webcast by adjusting the volume on your computer or by adjusting the volume on the webcast platform. If you are having technical problems with audio or the slide presentation, click on the question mark at the top right corner of the screen to access a list of system checks to try before contacting an online technician. If you do need a technician, type a message in the Ask a Question box and someone will get to you as quickly as possible. Individual technical questions will be answered in the Answered Questions box. Type your questions for our speaker in the Ask a Question box on the left side of the screen. The live Q&A session will begin after the presentation concludes. Today's webcast is being recorded. You will receive an email within a week with the link to the on-demand event. Download a certificate of completion and a PDF copy of the presentation. Use the Event Resources tab on the left side of the screen. Those documents will also be available with the on-demand version of the webcast. We'll pause here for a word from our sponsor. Please stay tuned. After the video, there may be a short pause to compensate for varying internet access speeds.
What the world needs now is people. People who see things just a little bit differently, who go out of their way to find a new perspective and a new way forward. Because seeing a smarter, healthier, cleaner world isn't something that's far in the future. It's something we're building now. GE, building a world that works.
Well, now I'm happy to introduce today's distinguished speaker. Steve Pavlovsky is the Principal Product Manager for GE Digital's Prophecy Historian and Data at the Edge program. With more than 30 years serving in automation and industrial data management, Steve is an industrial internet pioneer and a firm believer in the value and the power of data. Having worked with hundreds of customers, Steve is passionate about enabling organizations to get the most performance and reliability from their assets. Thanks so much for being with us, Steve. Over to you.
Thank you, Mark. I greatly appreciate that introduction, and thank you everyone for joining the webcast today. As Mark indicated, I've spent my whole career helping customers, starting out in the early days of HMI SCADA, all the way through today, where we're bringing the power of the industrial internet to our customers to help them wring out the next level of productivity from their operations. A little bit about GE Digital, who I work for. GE Digital is a core business within the GE company. So there are four big asset businesses: power, renewable energy, aviation, and healthcare. And then there's GE Digital, and we provide software to the industrial world, whether that be in grid and helping the majority of the electricity that's being distributed around the world through those utilities, bring that to market with our technology. To the manufacturing space where I'm focused and my business unit is focused, which is really helping, as you saw in the video, food and beverage, consumer packaged goods, life sciences, automotive, utilities, to get the most productivity out of their assets, to managing power generation and oil and gas and chemical manufacturing. So key big heavy industry applications where we really focus on enabling those customers to use data to drive their operations. That's really what we're all about, is how do we help customers use data to improve operations. And so that's what we're going to spend the next 35 or 40 minutes talking about. Interestingly, right, we all go through periods in our careers where we're going to look back and really sort of be amazed at sort of the change that occurred. And this last year is no different, right? We've all lived through mass changes, whether that be supply chain disruptions, impacts of labor, people not being able to come into plants, having to do innovation under pressure. Really, how are you going to keep your operations running efficiently to keep those operations actually viable businesses in this COVID-19 pandemic world? Disruption of and modification of channels, direct consumer increases, and feeding in new regulation, and then circularity, right? How can your business reduce its carbon footprint? Can make sure that everything that sort of goes out can be brought back in and recycled? We're seeing that as a challenge in the next sort of layer of green initiatives that companies are embarking on. So us that are in manufacturing space have always dealt with challenges. We always are facing, we've always faced operational challenges from our business, and how do we become more productive? What COVID-19 has done is actually, in many cases, accelerated that. Forced us to make business decisions that might not have been possible 3 years ago. Forced us to take, in some cases, people would have seen it as risky decisions 3 years ago in terms of providing data to workers or to supervisors on mobile devices, at a scale that didn't exist in the past. So these points in time drive change, and it'll be very interesting to see how we as manufacturers move forward with those changes. And the real critical thing is, as I was just saying, is those of us that are in the manufacturing space have to deal with the customer base, the user base within our facilities that need access to data. And that may have meant a shift from, they used to be able to, in 2019 or 2018, they could walk up to the machine, they could see what was happening. And they couldn't necessarily do that last year, right? Now, yes, we had people in the plants, but there were supervisory roles where people were staying out of the plants as much as possible, and having the ability to view data from the processes on mobile devices became a critical need. Well, that also means the data needed to be collected, right? So lots of change in terms of data collection infrastructure, data visualization infrastructure, mobile ready technologies. And this is not a trend that started during COVID, right? We've been talking about industrial IoT, or the industrial Internet of Things, since 2014, 2015, Industry 4.0, 2015, 2016 timeframe, right? So these are trends that have been occurring. What happened is COVID forced an acceleration, forced businesses to stop piloting in some cases and start executing, and just sort of get moving. And so that's really, I think, the sort of very interesting thing that COVID's done, is how it accelerated the data collection, visualization, analysis of data. And now what we're seeing is, now that we're going to see an acceleration of analytics, right? Because first of all, we've got an organizational change, new employees coming into the organizations in manufacturing that have skills, new sort of people coming into the manufacturing space out of school that know Python, right? So that's a skill that didn't really exist in the 2000s, right? Or even in the teens, right? There were specific individuals, data scientists, whoever, but the technology base, the knowledge base that the new employees that are coming into manufacturing is changing. We had COVID that changed. And frankly, the tool sets that manufacturers like ourselves are delivering to customers are changing to make it simpler to combine data from across the manufacturing value chain in this rapidly changing world to drive process variability. And that's really, tools to bring machine learning, artificial intelligence on top of now the new data that's being collected that occurred in support of the data visualization requirements in support of COVID. So it's really a very interesting time for businesses and thinking about, okay, now that we've expanded upon the data collection and visualization, what's next? What are the tool sets? And I think that's partly why you're here, is just some ideas on how you can help your businesses stay competitive by taking some leaps forward. And as we've worked with customers over many years, we see this as a journey, right? Starting with the connection, and I talked about that, the collecting of data, the storage of data, the visualization of data. Now we're moving into this analyzer analysis phase, prediction and optimization. So that's really the next step of the journey for many of our customers. And I mentioned Industry 4.0. It's really all about taking the machinery, right? Cyber physical systems really is nothing more than sensors, intelligent machinery, connecting them together in a way that allows for interoperability and the use of data, not within a machine, but across machines, and then broader across plants, across enterprises, and putting a structure around that, with the goal of making it easier to connect, making it easier to collect that data, store it, visualize it, and then leading to analysis, prediction, and optimization. So it's this journey that we're about helping customers move along. Right? You may be in the connection phase. You may have spent the last year and a half connecting and collecting data all the way through visualization. But now, how do you make more use out of that data? And so that's really what we're going to talk a bit about. So if we think about moving from sort of that very simple concept of connection, collection, storage, visualization, we'll talk a little then sort of next layer of detail, right? Which is how do you take advantage as an organization of that data that may be coming from now new sensors or newly connected machines, and how do you make the best use of it, whether that be at the plant level or at the enterprise level. And so let's talk a little bit about plant versus enterprise, or on-prem versus cloud, if you will, because those two things often go together. What we see is our customers have spent the time and have focused on building up the infrastructure to be starting on that journey, or taking a substantial step forward on that journey of all the way from connection through visualization of that data. And you may have good visualization at the site, at the line level, maybe even at the plant level. What the technology portfolios today exist from the major suppliers like GE is is the enablement of taking that data from the sensor, rolling it up at the machine, at the line, all the way to the enterprise level. Because really what you're after, especially when you've got multiple plants in your organization that are building similar products or the same products, as many of our customers do, what you can gain from the enterprise level analytics is an understanding of sort of within your organization, what's your entitlement? What's the best in class plant building a given product? And that could be along any measure, right? That could be labor productivity. It could be utility expense or raw material consumption. It could be overall sort of cost per unit, right? So understanding what are the key drivers of your business and where you're trying to, what levers you're trying to improve, right? You now have the ability, whether you bring that data in at the enterprise level or you're leveraging cloud technology, you have the ability to bring that data into centralized data stores for enterprise level analytics that's going to allow you to understand which of your plants is best. Once you understand which of your plants is best on any of those measures, right, then you can start to understand, okay, what do I have to do at the other plants to attain that level of productivity? And whether that be materials, energy, labor, whatever the thread is. And all the while, you're continuing at each of your plants to be doing local visualization, local analytics to improve the performance of each plant, including that today best-in-class plant. Your expectation is it's going to continue to improve as well. And the improvements that you learn there, you want to be exposing to the rest of your organization. So the loop is a little bit bigger, right? Within a plant, it's easy to have discussions around a machine, or as you're walking the floor. We're a big proponent of lean, right? Walking the floor, doing Gemba visits, on your daily routine, walking the floor, talking to the operators around what problems you can help them solve. That's an easy sort of visual. Now, how do you expand that to the plant and enterprise level, right? It takes a little bit more structure, takes a little bit more thought, but the same notion, understanding what goals do you have that are worth solving? What problems do you want to continue? Where do you have best in class? What's your benchmark? And then working at the non-best in class or to help them attain the benchmark. So let's talk a little bit about the how, right? We see, and this is a Gartner framework, right, around data maturity, right? So descriptive, that was really around what I was talking about before, the connecting, collecting, visualization, sort of what happened, or what's happening and then why did it happen, which is sort of that next level of diagnostics, which visual analysis, traditional trend analysis, correlations of alarms versus data may help you get to that level, right? Then as you start to look for what will happen, there's a lot of talk in the industry around digital twins. Digital twins are nothing more than process models that allow you to run scenarios. Primary scenario is feeding the inputs from the current process, but also being able to potentially run scenarios around what if I changed a particular parameter, what does the model say? If to closing that loop, which is the prescriptive piece, if I have a closed loop system and I'm seeing data and I'm collecting data and I'm feeding that data into my predictive model, right? I can predict that a process failure is going to occur, a quality issue is going to occur. Then I can start to think about, when that has happened in the past, what action did I take? Whether that be equipment change, could be process change, and that's where you get to this notion of optimization. So Gartner's model here is very similar to that circular process that we talked about 3 or 4 slides back. A simpler version in sort of lean jargon is this plan, do, check, act cycle. And we do this with customers on a local basis where we are really working with them to continuously iterate. And that's a big piece of lean, is continuous improvement. And we work with customers in this sort of 4-stage cycle because it's easy to sort of grasp. And this is actually an example that I'll sort of walk through how one of our customers happened to be using our digital technology, uses the technology in this cycle, and the roles of the people that are engaged, because the roles of the people are changing. As I grew up, started in the early HMI SCADA days, all the way through today, right? You've got tag names, right? And tag names representing process variables, which are really being brought into the system through sensors. What's happening today with the more easily deployed asset models and mapping and contextual representations of data, goal here is really to push the ability lower and lower in the organization to create visualizations, to create analyses that help improve the process on a daily, weekly basis as part of a daily management routine. So here's a particular cycle that one of our customer uses. So they have a digital team that's sort of the first people that are knowledgeable about a tool set. However, these are not IT people. These are people with skills and interest. So they could be line supervisors. They could be process engineers. People with some level of technology interest, but not necessarily not part of the IT organization. So folks that are kind of embedded within the organization, working with operators, line supervisors, and managers to understand what are the challenges. And part of the challenges is understanding what data do the operators or do the supervisors need to see to be able to make progress on those challenges. And so this digital team creates, makes sure that the data is available, brings that data into visualization tools, and helps create analyses, whether that be sort of tabular or trend analyses, or potentially even create analytics using sort of out-of-the-box tools to create visualizations and to create information that helps those people closest to the process make better informed decisions. And they validate, right? Did the new tools, did the new screens meet the needs? Did the operators, did the line supervisors or the area supervisors get the information that they needed to help improve the process? And where they can improve, they sort of restart that cycle. So the digital team, again, people embedded within that manufacturing organization, actually then go back and tweak, right? So it's this continuous improvement cycle of the tools in support of continuous improvement of the process. And so that's a very interesting and very powerful concept. We use, and I think it was on the sort of introduction to this section slide, democratization of data, right? If we think about a manufacturing operation and they've got an HMI system and they're collecting tags out of their PLCs into that HMI system, if what they're looking to do is sort of enable the most people in the organization to get value from the data, they have to find ways to make the data more visible and more valuable to more people. So that can be putting context around the data, whether that be an asset model or whether that be visualization tools, such as some of the UX tools and the sort of what you see is what you get type editors, building tools, building displays that are available in the market today. And so as we think about making those tool decisions, right, that's sort of the next step. If you want and your organization is going to move along this journey, then it's important to be, as you're making the next generation of software tool decisions, it's important to be thinking differently about the tool decisions that you're making than you might have 2 years ago, right? So as you're thinking about your projects, where is the data? Who's in control? What are obviously safety? You've got to have interoperability. Scalability is an interesting piece, right? This is not an HMI SCADA system for a user. The real question is, how can as many people in the organization get value from the data that's being collected as possible? So what has to get added perhaps on top of the HMI SCADA system that's in a plant, or on top of the HMI that's on a machine, to help more people get access to the right data at the right time, and sit on seamless integration with existing apps. You've got an infrastructure of technology today. So the question is, if your goal is really to drive integration of that data through the technology and bring data to a broader set of folks, right? You've got to be thinking about what's the integration capability. And we talk about a couple of other elements, right? We talk about rapid application development tools. So instead of traditional building HMI screens, or that only a certain, only people with an HMI SCADA license and a particular machine operator can see, right? New web-based tools with simple to deploy editors, enabling the rapid iteration of apps or of displays is important. Object orientation. You've got common machinery. You want to build a display or an app associated with a machine type and then sort of replicate it, or not even replicate it, have it be driven in the context of an asset model. So I, as an operator, I want to see the data associated with machine 1. There's another operator looking at machine 2. They're looking at the exact same display, but populated with different data in the context of an asset model, because you've got objects, visualization objects or applications tied to an asset model. That asset model is tied to the data associated with the assets. So the user doesn't have to understand sort of the data structure. What they're following is an asset tree through the application and being presented with the data that they have said is important for them to help them do their job. And that's all in support of this notion of incremental development, constant refreshing, a constant iteration and improvement of the tools in support of improvement of the process. As we think about analysis and analytics, right, and many of you that are in operations, you've been doing SPC over the years, right? You have a basic understanding of this, right? There's really a 3-step process, right? It's really about understanding process variation. What are the sources of process variation? How wide is the variation within your process? Then there's the monitoring and leading to prediction, which is really about reducing process variation and narrowing down that bell curve from very wide to narrow, but while keeping it center lined. And then you're getting towards simulation and optimization. I talked about digital twins before. It's really just another language around describing simulation and optimization, where you're running scenarios. You've got models that will help you understand and predict, based on real world inputs coming into that model, what's going to happen, because the models can run faster than the actual process. Or you could actually run scenarios in parallel, saying, what if I change a particular parameter? What's the process going to do? And that's really where you're getting to optimization, because you're now having the ability to run scenarios in parallel that help you understand what the impact of changing parameters is on your process. And I'll give you an interesting use case of this. So we worked with our power business, who works with power generation utilities. And the power generation utility market's interesting, at least in North America. Utility operators sort of bid a schedule, and they bid a price for power that they're going to generate the next day. and then the ISOs sort of award a particular power generator. Yep, we're going to buy so many megawatts from you over the course of this day, other power, and it's done on kind of an hour-by-hour basis. Well, you think, when you take into account a turbine that's generating power, effectively has a life cycle in between retrofits, and they can either extend the life of that turbine, but that time period is fixed. But effectively, they can consume more life or consume less life by overrunning or underrunning the turbine from its baseline load. If you're able to do analyses and predictions, you're able to actually change your bidding process and bid that you want to win more business on high volume days, or take into account other things that you might know that are happening in your particular grid market, like one producer's going offline for a maintenance interval. And we've helped utilities actually generate $1 million of incremental profit a year, living within their retrofit period, by building digital twins or analytic models of their equipment, and then figuring out and running scenarios from today to the end of their maintenance period as to which days do they want to overrun the turbine, which days do they underrun the turbine, so that they can make the most profit. So there's lots of different ways of thinking about this simulation and optimization. It's really understanding, what are you trying to optimize for? Are you trying to optimize for quality? Are you trying to optimize for profit, for productivity, for environmental consumption? So there's really this, the capabilities there. The question is really, what are the barriers to your organization to adopting this technology, right? Right. You have data today. You may have process engineers that have tools anywhere from Minitab to do statistical analysis on data that's been collected, to you're doing live data collection and you're doing trend analysis in a visualization tool, or you're bringing data into Excel and they're doing analyses, to, how do you get more people involved, right? Maybe you have data scientists, maybe you don't. And that's part of the notion here, is many of the customer organizations that we talked to that have wanted to take advantage of analytics have had organizational structural issues. So they've had process people. They have people that understand the process, but often there's two other roles that have to exist in an organization, especially with the tools of the past, to be effective at doing analytics. And that is a data scientist. And a data scientist is really a person that understands the data that exists, understands how to ensure that the quality of the data that's being fed into an analysis, it's the right data and the quality is good enough to have an outcome that's of value. And then oftentimes there hadn't been an analytics programmer, a Python coder, whatever, to build an analytic. And so that's part of what's changing, is the tool sets are becoming richer that allow even the process engineer who has access to data to be able to combine that data in a common tool. So maybe they've got data coming out of a SCADA system, or multiple SCADA systems or multiple HMIs. Maybe they're bringing that data into a historian type product, but maybe they also have an alarm and event data. Maybe they have other sources of data that they want to be able to combine. So the tools today allow for the combination of multiple data sources and multiple types of data. There are automatic tools that can help prepare the data for analysis, ensuring that the data doesn't have data quality issues, that there are not a lot of outliers. They can provide plots of the data so you can see, is my data relatively, does it make sense, or do I have a lot of outliers? They can even identify root cause. A lot of times what will happen is our customers will have they've got 100 or 500 process parameters associated with a given process. Well, how do you understand which actual KPIs or which pieces of data that you're collecting actually correlate to the machine or the process behavior? So the tools now provide that correlation, identifying the critical few KPIs that have to be monitored. And once you understand the critical KPIs, now it's possible then to start to build with the tools that are existing today. Even the process engineers, if they have interest in a little bit of learning, can build simple machine learning algorithms that watch those critical few KPIs, put them into a runtime environment such that they can be sitting there monitoring the real-time data or near real-time data that's coming in, and create alerts that could not be determined by the traditional HMI SCADA system to potential quality problems or other process problems. So that's really, that set of tools is now possible, but you have to be thinking about, sort of 2 pages before, you have to be thinking about, how am I going to bring my data together, let's say within the plant, to enable that process engineer? Or as you start to move from, that's sort of the role of on-prem, right? How do I improve my given piece of equipment? What analytics do I want to run that help me with closed loop control using machine learning tools, which are easily accessible today to your organizations, right? How do you ensure that the data is visible to the right people and only the right people, and make sure that the data is not being published overly broadly, right? How do you now start to take, as you're doing that closed loop control, what are your industry guidelines and what is your business guidelines on closed loop control, right? In these types of computer systems, are you providing feedback to operators, or are you actually going to close the loop? These are all decisions that are within your control, to enable you to make decisions on how you want to invest to improve the sort of operations of a given location. And then what are the possible benefits, right? So you may be focused on avoiding downtime. So your analytics may be really focused on identifying causes of machine failure or equipment failure. You may want to be focused on production throughput. Your challenge may be productivity. It may be throughput, and throughput could be caused by quality issues where you're having to discard or rework product, or it may be just bottlenecks. And so how can you use analytics to help you understand where do you have process bottlenecks so that you can actually alleviate those bottlenecks, right? And we've seen customers actually improve sort of throughput, quality, productivity of operations up to 10% by using in-plant analytics. And I'll go through a couple of examples of customers that have done such that. Then beyond in-plant, right? Now what's the role of cloud-based analytics? And I mentioned this a little bit before, right? This is really about how are you going to learn use what you're learning in the plants to improve the overall enterprise. So whether that's you've collected the data up at the enterprise level, or often today what we find is enterprises are making buying decisions that say we're going to have a spend with Amazon AWS, right? Or we're going to have an annual spend. This is CIO level decisions. We're going to have an annual spend with Microsoft Azure or other cloud provider, right? Because we don't want to be in the data center business anymore. So we want to use their cloud infrastructure. And many of the business intelligence tools that we either have been using on-prem are available in the cloud. So the Power BIs, the Tableaus of that exist. And there's a new set of, we want to be able to bring our transactional data, our process data from across the enterprise into data lake technology to bring that data together such that we can use, in the AWS case, SageMaker, for example, analytics on that data to really understand which of our plants, which of our equipment is delivering with the best productivity, where do we see opportunities for improving productivity, all the way to understanding what's raw material consumption across the organization and what are the potential impacts if at the sort of corporate sourcing level of visibility to shortages and disruptions in supply chain, to perhaps understanding which plants are most profitable and directing raw material to the most profitable plants to sort of preserve profitability of the overall organization. So there's decisions that can be made at the cloud, at the enterprise level, if you're bringing the right subset of data at the right frequency from the OT systems, from the analytics platforms to the cloud, that you can't do if the data stays at the plant level. And this has been a constant, right? Data at a sensor has very little value. Data at a machine level has value at the machine level for improving that machine. It's really a matter of, all right, the farther up I go into the enterprise, and actually additional layers of value get created on that data. And so that's really the important piece here. And so, as we think through the journey, right, it's really about reducing process variability, enabling faster troubleshooting, increasing productivity, decreasing downtime, optimization, and all supported with improved data integrity, right? So that's really a notion here of sort of a summary of what we've just spent the last several minutes talking about. Two quick examples, right? So we have a chemical customer who use these types of analytics to monitor their PID loops. And that provided daily reports to the staff. The right people were getting the right data on a daily basis, so they could easily identify issues, minimize process deviations, and improve and deliver better decision making at the right level of the organization to optimize the process and availability. Their focus was plant availability. A very large CPG customer that we work with was really focused on, had an initiative around, a green initiative around reducing consumption. And so they used cloud level analytics to help them understand what the energy consumption, and they used the term wages, which is water, air, gas, electricity, and steam. So all of the ways, all sort of the utilities within the plants, and really help them understand where did they have leakage, which plants that were making similar products were most productive from a utility perspective, and then help them go search for what's different in one plant versus another to help them improve the utility consumption within those plants. So lots of different opportunities that are possible, And so lastly, sort of in summary here, right? I think there's a notion here that you've got to be thinking forward looking as you're making your software buying decisions, looking at capabilities of bringing that data together, both on-prem in the plant level, and then how are you going to take data and expose it to the enterprise? Working within your organization to set a frequent cadence of improvement. In the lean world, we talk about daily management. Daily management doesn't have to be daily. It can be weekly, but it's a rigor around periodic. Where do we stand versus our KPIs? Where are we red? What do we need to do to get back on track? And that may be even improving the tools. So you got to have goals as to what problem you're trying to solve, that you're trying to daily manage around. Understand those goals. Are they driving enterprise or plant level decisions? Making sure that you're not tied into technology that's going to make it more difficult to scale, right? The data, more value from the data is going to be created the farther up the food chain it goes into the enterprise. So be thinking about buying technology that's going to enable that. You may not be planning it today, but 3 years from now, 2 years from now, the leaders of the enterprise are going to say, hey, I want to bring all this data together from plants. It's going to happen because your competitors are going to be doing it. And then just really this is something that's always been the case. Look at off-the-shelf capabilities and extensibility of tools. Think about the usability of those tools and who's going to be able to use them in your organization. And then lastly, I think all of us have lived through, what we'll call science experiments or pilot purgatory. And frankly, I think the year of COVID or the 18 months of COVID have caused us to act more rapidly throughout our organizations, and we have to keep that momentum up. So keep doing, not playing, is sort of my last point. And with that, Mark, I think we're about ready to turn it over to you to lead us through Q&A.
Thank you, Steve. We have time for some questions. The audience may type questions for the presenter in the Ask a Question box on the screen. We'll get to as many questions as time allows. Questions that we don't get to today will be posted online at controleng.com with the archived version of the webcast. So keep asking the questions. Remember to download a certificate of completion or a copy of the presentation. Use the Event Resources tab on the left side of the screen. And now on to the questions. So what's the best way to prioritize digitization efforts if I'm managing multiple plants?
So that if you're managing multiple plants, then you have a set of goals associated with those plants. And depending on your situation, you may have multiple plants that are all producing vastly different products, or you may have plants that are building the same product, but perhaps just located in different geographies. So first of all, it's a notion of really what's your goal? And is it a goal that's shared across plants, or is it a goal in a way that you can compare the performance of plants at a detail level, not something like productivity, right? Of course, you want all of your plants to be increasing in productivity. But if you've got plants producing common products, then you have the ability to use analytics or analyses differently that help you understand what's the actual performance of plant A versus plant B, and then look at the learnings from your most productive plant and try to apply them into your other plants. So it's really, I think it's first starting with an understanding what you're trying to solve, and then go from there.
Great, thanks. What are some immediate outcomes that I can expect from digitization efforts?
So for us, this is really about getting more value from the data by giving more people in the organization visibility to the data to help them make better decisions. So often, right, machine operators had an HMI system they could see, right? Line supervisors get summary data. But maybe there are analysts, maybe there are production engineers or equipment engineers or quality engineers that could benefit from, say, near real-time data, or be alerted to a quality problem on a machine, and then move to that operator and say, what can we do on a rapid basis to either to make a change. So to me, it's really about getting data into the right people's hands on a more rapid basis, so that change can occur faster.
Great, thanks. So what skills are required to develop and implement digital twins?
So digital twins, right? If you're gonna take the step to digital twins, right? I talked about sort of three key elements that have traditionally existed in sort of the data science or analytics world, right? You have to have process knowledge. So typically a process engineer or somebody that's really knowledgeable about the process. You've got to have, and then you've got to have tools where you're collecting the data, understanding what the critical KPIs are. You've got to have, either tools or people, right, that can help you ensure that you've got good quality data that's being collected, that you don't have sensors giving you bad data that are going to give you bad results from your predictions. And then you have to have the skills of how's the actual digital twin going to get built, right? Are you going to use sort of an off-the-shelf tool that lets you build canned modules together to do machine learning and build a query, or are you going to build something custom? And some of that's dependent on the scale. But you've really got those three sets of tasks, and you've either got to have people or you've got to have tools that sort of help you fulfill those tasks.
Great. How about some advice on how to separate out variations due to external factors versus those due to internal performance problems?
Yeah, so there's a couple of thoughts come to mind on that. We actually introduced a solution earlier this year, which monitors. So we have customers there; they've perhaps got a SCADA system, or they've got PLCs, and they're storing that data. What they don't know is, what sensors do they have in their plant that are causing bad data, right? They may be seeing alarms. Their operators may be saying, well, the process is running fine, so they're just acknowledging alarms and move on. And so what we've done is built an analytics application that can just constantly be monitoring the data that you're collecting and watching for anomalies in your data that help you understand, oh, this is likely to be, I have a sensor problem. So think of a temperature of a tank, right? That temperature physically can't change very rapidly. But if the value changes rapidly, or does a step change, or drops from, effectively 75 degrees Celsius to 25 degrees Celsius, and it's a liquid, right? There are technologies that can be there monitoring your data to ensure that you are alerted to external influences like bad sensors that are polluting your data, and help you rectify that on a more rapid basis. We've actually found, I don't think it's us. I think there's been industry data shows that up to 10% of the sensors in any given plant can be providing some level of faulty data. And so for us, that's a very critical piece. If you're trying to do analytics or you're trying to build predictive models, you have to have ways of ensuring that data is good.
Great, thanks. Let's see. I'm getting that that digital is primarily oriented to the predictive health monitoring areas. If that's correct, how scalable is your digital models that you're creating?
Yeah, so that's a great question. So we have a variety of solutions that help customers all along that journey, from the data collection, visualization, and maybe that's where they stand on the journey, to machine level or plant level analytics, all the way through digital twins. And some of our largest customers run many complex analyses on thousands of assets. One example is GE Power. GE Power collects data from about 3,500 heavy-duty gas turbines around the world that are being used at utilities. They bring that data into a central monitoring center. So they bring about a tenth of the data that's collected locally on the machine in for central monitoring, where they have a whole range of complex analytics that are monitoring the health of those assets and predicting failure, or validating that failure is not going to occur based on the data that's being collected, and alerting customers when the models indicate a potential issue. So we have a range of tools that allow for supporting customers anywhere along that journey, all the way from sort of very small point solutions up through the very largest solutions.
Good. For a company that's never dabbled in data analytics, what's the best way to start taking advantage of the benefits of this and other technologies for machine learning and artificial intelligence?
Yeah, so that's really interesting, right? So, I would say as a GE Digital representative, right? We have tools with very, very low entry sort of pilot offerings where you could be collecting, say, 100 different process variables at spending almost no money, and we provide some educational services along with that. So you could look to a vendor like ourselves or other vendors in this space. You could bring in interns, right? If you've got summer interns coming out of engineering school that understand Python, right? They have ideas on how to use these technologies that you may not actually have visibility to. And so that's another way on a very low cost basis to really sort of start to understand how these technologies can be applied in a way that you may not be thinking about.
Well, great. Time for one more question. In the use of digital twins, any advice on first validating digital twins and then the results of the predictions versus actual results?
Yeah, so that's really a very interesting question, and we could talk at length on that. Clearly, validation of the models is a critical piece, right? And the more similar assets that you've got that you can run the data against, the better. But yes, there's obviously a critical piece of model validation. And then periodically, right, as you're running, if you're using the digital twin to run scenarios, right, at some point in the future, does that real world scenario exist, and can you revalidate? So it's an interesting question in terms of the predictive models. It's easier to sort of validate the sort of near real time predictions. But the predictive models do present a little bit more challenge in terms of, how do you really understand what the results of the prediction were, especially if that scenario is never really used in the real world.
Please continue to submit your questions. We'll get to those offline, but for now, I'd like to offer my sincere thanks to Steve Pavlovsky, the Principal Product Manager for GE Digital's Prophecy Historian and Data to the Edge program. I'd also like to extend a special thanks to our sponsor, GE Digital, for sponsoring today's event. And now that we're just about done, we want to hear how we did. The exit survey will pop up on the screen as soon as the webcast ends. Please take a moment to complete it as we use this information to improve our webcasts. So on behalf of Control Engineering and GE Digital, I'd like to thank you for attending. This concludes our webcast. Thank you and goodbye.